Okay, so we are going to look about my script that is the Jesus robot control. In this script, the idea is that we can control with text and to do some operations instead of numbers. So maybe it is easier for humans to understand what we are aiming to do. The idea of the project, well, of the homework is that we can send messages, for example, the message move forward to the recognizer slash output topic, and at the end we translate it to some velocities of the angular z and also to the linear x. The requirements are to move forward, move back, turn left, and turn right. Finally, we should be able to stop our robot and also to propose an additional command to it. Also we are required to have a launch file. So let's jump to the code. First, we need to understand that in this project we're using Python 3. We have the same operation to import who is the interpreter. We have our imports for the Python library. We have these RR that are for regex, regular expressions, and we use this data class to handle our typing in the project. We are going to jump later. The idea is that if the program is the main one, we're going to initialize a node with the name robot control node, and also some lines will be appended to it. It creates an instance of the robot control, and if something goes wrong, we print the error and also send the message that something wrong happened. Inside the class that we have right here, we have our constructor. The constructor is the first method that we have, and also we have some robot instructions that we are gonna look later. Yeah, in the constructor, that is the initializer, we put that when something when we receive the shutdown signal, this callback will be executed. What is going to be executed? We are going to stop our robot, and also the speed factor, that is a variable, that is the other instruction that we have, that we can increase or decrease the velocity in what an action can be executed, and return to the initial value. And also we publish that the linear x and the angular z are going to be 0. That's all about this callback, the cleanup. The stop, in the stop we only have that we receive an action, we log it, and the action is the linear x. Then we print that we are gonna set in a publisher. The publisher, we are gonna be sending messages to the command velocity topic that we have previously. The type of message is a twist that has 2 vectors. In case we cannot, well, it cannot handle the messages, we put that it should store at least 2 elements. Well, at maximum, sorry, 2 elements. And the publishers, well, they are okay set up. The subscriptions, we have the recognizer output, that is a string, and the callback that will be handled, that action is the recognizer callback. And also we have an instruction to reset our values to 0, so everything starts from the initial point. And we have that the node is going to be sent at 1 Hz. We put it right here, the frequency that we are setting up. We have our linear x that are 0, so the robot does not have any action at the beginning. The angular 0, and the speed factor is 1. The factor is only the other number that multiplies the linear or the angular c. We have right here that we log what is the speed factor in case that we are trying to debug. We put the sleep, and also we moved the logic of our program to outside the constructor. Well, it is also inside the constructor, but in the class can be outside just to clean it up. Inside we have the linear c that is a variable that we are going to publish to our velocity, and it is the multiplication of the class variable that is the object variable that is the linear x times the speed factor that if it is 1 it doesn't affect, and we have the linear x by default. The angular c is also the same with the object variables, and we publish that message to at the end. We use this helper to simplify the robot communication, so we are not going to have it in multiple times the vector and some stuff like that. The reason that we simplified it is because we only could move to the x-axis in the linear part, and in the angular we only can modify the c. We log the message just for debugging purposes, and also we deconstruct our tuple right here with the star symbol. We are using the velocity publisher. Then after, well, that's all about the main program. Then we are going to look the reset. The reset, as I mentioned previously, is only put the object variables to its initial values. That's all. We don't do any action. And about the recognizer callback, that can be the more complicated. When we receive a message right here in the recognizer output, we mentioned that it will be a message, and the message is gonna receive a data message string of this type. This is a data class, and that the reason that we do that is that we are expecting to have a property that is called the data, and with the typing we are sure that this data is a string. It is pretty easy to handle and to identify errors with the typing, so that's the reason that we include this data message string. The difference between a class that has this I forget the name well, this is sugar syntax to wrap the data message str. I forgot the name. What is the name of this? But it will grab the data message string, and it will have a property that is called data, and it is a string, and we can modify the typing. And the reason to have it is because we can compare between data and data objects. They could be in different references in the disk board or in the memory, but if they have the same raw values, that will matter. That's the only that will matter to us. Right here in the recognizer callback, we have a router. Then the router is only a dictionary in Python. That, for example, if we receive the move forward, we are gonna send the callback, that is move forward. If we receive move back, we are gonna send the move back, the turn left, the turn right, the stop, the increase speed, the decrease speed. The instruction will be from the data. We are gonna remove the spaces that can be in the left and in the right side. We convert it to uppercase because we want to match it to this part. Also, we have the regular expression that, for example, if we have, or the user send move forward with multiple spaces, we can link them with this. In case that we are not able to link the instruction that we receive, we are gonna send a NOP, that the NOP is a short for not operation, and that's all. That we're not gonna do that. We can send, for example, maybe that it receives an invalid instruction, that we did here, but that's all. And as we have a function right here, we only call it, and that's all about our code. We can jump to the move forward. The move forward, we have the login, that the new action that receives is the move forward, to set the linear x to 0.1 and the angular to 0 because we don't want to move it. The move back is something similar but with negative. The turn left, we only move the angular axis. The turn right, we move it in the opposite direction. The stop, we don't want any movement, so we set it to 0. The increase speed, we do some increases by 0.5 resolution, and we have a limit of 4. That is our factor. So for example, if our base speed is 0.1 times 4, the maximum speed that we are going to have is 0.4, and that's all. We use the minimum because we don't want a value greater than 4 in this case, and the decrease is almost the same, but we don't have any value less than 0.5. Related to the non-operation, we already said that this is an invalid operation. It cannot be done anything, and well, this static method is to tell that the class that we are not using any self right here, and that's all about it. That's all about it. So we can jump to our Catkin list. We include it right here. We can make a Catkin make. It's gonna load. Yeah, I remember the name. It is a decorator. A decorator. Related to our launch file, we have the launch. We use this include to launch our Gazebo ROS. It's gonna launch the empty world launch, the other file. The two wheels are going to launch the spawn launch. And finally, we have that we are gonna call our package beginner tutorials, and the type that we're gonna call is the Jesus underscore robot underscore control.py. That's all about it. I didn't put any namespace because we don't have any, well, yeah, we don't have any duplicated node. For simplicity, I consider that it was not necessary. To call our launch file, we use the ROS launch command. And the name of the package is beginners tutorials, and the name of the launch file is robot control launch. We are gonna wait. It is starting. Yeah, we have it right there. Here is our robot. We can do a ROS topic echo of what's going on in our command velocity. And right here we have our command velocity. We can split right and send ROS topic up of the topic that is called, what is the name of the topic? Recognizer. And the data. That's all that we have. Just to send it once, the increase speed. It will not alter these values because it is a stop, but if we send, for example, move back, I guess that's a command. the robot is move it back. If we say something strange, it doesn't move back. This is the speed. We can move forward. The robot is moving forward. Here we have what are the commands that are being sent. It moves strange because it has the arm that we don't have. Yeah. And we can stop our robot. Stop. Here we have our robot. We can tell it to turn left. It is moving right there. We can increase the speed. Increase the speed. Take a look. It is 0.2. We can increase again. It is 0.25. Once more, just to reach the maximum value. 3. 3.5, 35, sorry, and 40. That is our maximum value. We try to increase it again. We have the limit. And we can mention that it should move forward again. Did I write it right? No, I didn't write it right. That's the reason that it didn't move forward. I guess that's the right. Whoa, it is too much speed. Let's decrease the speed. Decrease speed. And just follow the robot. Follow the robot. Decrease the speed, decrease again. Let's mention to turn. I guess I turned left, but again, let's turn left and turn right. In the opposite direction. Stop. And that's all about our robot that we have. Let's close the program. The robot control now died. That's all. Stop the record.